Good day, ladies and gentlemen personalities. Today I want us to discuss a very important rule in calculus, which is called a power rule. So what does the power rule say? Power rule says that if you are going to have y which is equal to a x to the power n, right? If you've got y which is a x to the power n, then dy over dx. What is dy over dx? Dy over dx is the derivative of this function. All right, so dy over dx is nothing other than, then what you simply do is that you take this n that is on top and then you multiply it with this a, which is a coefficient of what is here. So you will end up with n times what? Times a, and then x to the power n, right? And then but now then you then minus 1 here. Doesn't make sense. So what does it say? It says that if you've got y which is equal to ax to the power n, therefore your dy over dx is nothing other than you take this n to this side and it becomes n times ax, and then you take this n that is here and you minus it by 1. All right, let me make an example. Let's say you've got y which is equal to, say, 2x cubed. So because of this rule, that is power rule, therefore your dy over dx is going to be, you take this 2 to this side and then you're going to say 2 times, sorry, this 3, you're going to say 3 times this 2 that is here, and then x, and then you're going to have this 3 that was already here, and then you say 3 and then you minus it by 1. And then so what do you get at the end of the day? 3 times 2 is going to be 6, and then x, and then 3 minus 1 is going to be 2, so 6x squared. So the derivative of 2x cubed is equal to 6x squared. Okay, that is what? That is a power rule. So it simply says that if you have a function that has a power, you can simply take that power and multiply it with a coefficient, and then the same power you minus it by what? You minus it by 1. Okay. Now here we made an example with dy over dx. That is one of the ways in which we can represent what? In which we can represent a derivative. But there are other ways. Say for example you had a function which is called f at x, then you can still write the power rule in terms of f at x. So how do you then do that? You say if f at x is equal to ax to the power n, therefore f prime at x is what? You take this n to this side, you say n times a, and then x, and then you take this n, you minus it by what? You minus it by 1. Okay, so in this time round, your function is, the name of your function is f at x. Okay, here the name of the function was y. So because of your function was y here, then the derivative is dy over dx. And then here you've got f at x, so your function is, your derivative is what? Is f prime at x. Do you understand? The rule is just the same. So this rule and then this rule is exactly the same. It's just that it is written in different format. Okay, now let us give another example. Let's say you have f at x, which is equal to 2x, say, to the power 5. So when you find f prime at x here, how do you find f prime at x? Using the power rule, you will say f prime at x is what? F prime at x, you take this power to this side, and then you will say 2x, and then you take this power and you minus it by 1, and you say 5 minus 1, that is what? That is 4. All right. Wonderful. So you have found the derivative of this function using a power rule. Now, ladies and gentlemen, personalities, let us say you now have something like this. Okay, let's put this here. Let's say now you've got something like this. You've got f at x now, which is equal to 3x. And then they are saying to you, find f prime at x. How do you go about finding f prime at x? Okay, when you look at this thing, the first thing that you will need to realize here is the fact that 3x is same as what? Is same as 3x to the power 1. There is an invisible 1 here. Okay. Now, before I even go further, I just want to explain one thing, ladies and gentlemen. The power rule works if there is a power. What is a power? Remember, when you're speaking about the term, this is a coefficient, this is a base or a variable, and then this is a power. That is why it's called a power rule, because you find the derivative playing around with this thing, which is a power. So you cannot be able to use a power rule if you have not recognized where the power is. Okay, so that is why it was important to remember here that 3x is same as 3x to the power 1. So there is a power. So because there is a power, therefore I can use a power rule. I can't use a power rule if there is no power. So how do I then use it? Okay, I then say, okay, now because I have f at x, which is equal to x squared, so I take this one to this side. So I say my f prime at x is nothing other than, you take this one to this side, and then you say 1 times 3 is what? Then you say 3, right? And then you say x, and then you say 1 minus 1, right? So what is 1 minus 1? 1 minus 1 is 0. So you've got x, 3x to the power 0. And from the exponent rule, ladies and gentlemen, personalities, we do remember that anything to the power 0 is equal to what? Is equal to 1. So because of that, this is same as 3 times 1, which is equal to 3. So the derivative of 3x is nothing other than 3. Right? Wonderful. Now, let us say, ladies and gentlemen, personalities, we are now given something like this. Let's say we got f at x, which is equal to, say, 4. And then they say find f prime at x. So what do we do in this case? What do we do in this case? Ladies and gentlemen, personalities, there is something that I want you guys to notice. I do not know. Now, see, so this is in terms of x. So f at x is equal to 4. So basically, this is same as what? This is same as 4x, but now to the power what? To the power 0. Do you remember here? 3x to the power 0 was then gave us 3. Okay, so here 4x to the power 0 give us what? 4. Can you see that? So this and this are exactly the same thing. It's just that this one is expressed in terms of x. But don't worry, in terms of your grade 12 syllabus that you are part of, then you definitely won't need to do this. You have to go straight to the answer. So it doesn't matter. So basically, I just wanted to show you where it comes from. So basically, if this is 4x, therefore if you were to find f prime at x here, so f prime at x here will be what? It will be 0 times 4. So 0 times 4, and then you will have x, and then you will have 0 minus what? Minus 1, right? In term, because this is how a power rule tells us that this is how we deal with this kind of methods. Okay, so I don't even care what is going to come out of here, but anything that is multiplied by 0, what is going to happen to it? This 0 times 4 is going to be what? 0. 0 times x is going to be give us 0, so we'll end up with 0. So basically the what you call the derivative of 4 is what? Is nothing other than what? Is nothing other than 0. Okay, so basically this then brings us to a rule that, okay, let me write this rule with a different color, which is very important. So if y is equal to what? Is equal to c, right? Then dy over dx is equal to 0. So whenever you are looking for a derivative of any number, whether it's negative or when it's positive, then you always get 0. So for example, if your y is minus 2, therefore your dy over dx is going to be what? It's going to be 0. If your y is minus 100, we don't care, your dy over dx is going to be what? It's going to be 0. And this comes from this rule. Okay, this comes from this rule. I just wanted to show you. But basically the bottom line, what you should remember for your test and for your exams, is the fact that the derivative of what? The derivative of any number or a constant is nothing other than what? Is nothing other than 0. Okay, do you get that? All right, now I want us to discuss something else which is important. Now, okay, so what I did is, you saw how we found the derivative of this one number, right, using the power rule, right? And then now we also showed you how to use this one, the one with an invisible one here, and then you know how to find the derivative of that, and then you know how to find the derivative of a constant. Okay, so now what if now you've got something like this? What if you've got something like this one? So you've got f at x, which is equal to, say, 2x to the power 3 minus 3x plus 4x minus 1. So you've got a problem like this one. The question is, how do you then, okay, let me put squared here, squared. So they say find f prime at x. Okay, so ladies and gentlemen, personal teachers, this is now, it has a power, ne? And then this one also has a power, and then this one also has a power, and then from what we did earlier, we know that this one also has a power. It's just that it's not written in that form that shows here. But basically, all of these numbers have powers. So because of that, we can then use what? We can then use a power rule. Okay, so what we are going to do in order to find the derivative of this, we are going to apply the power rule in each of these numbers. Okay, so now if we do that, what is it that is going to happen? So what will happen is, so f prime at x is nothing other than, then you take this 2 to the side, then you'll have what? You'll have 3 times 2x to the power 3 minus 1. And then you take this 2 to this side as well, and then you have this minus, right? Minus this 2 that was on top, 2 times 3, and then you have x, and then you've got 2 minus 1. And then when it comes to this 4, you take this invisible one that is here, you multiply it, you get what? You get plus 1 times 4x, and then what? And then you've got 1 minus 1. Here you can just say minus 0. It's fine, because we all know that the derivative of a constant is what? It's 0. Okay, so from here, what is it that then happens? 3 times 2, you've got 6x, and then to the power, and then 3 minus 1 is what? Is 2. Okay, and then minus 2 times 3 is 6, and then 2 minus 1, so you put x and then you leave it like this. And then 1 times 4 is going to be plus 4, and then x, you've got this x, and then this x, remember, you've got x, which is to the power 0, right? Yes. And then obviously, you know, anything to the power 0 is what? Is 1. So this then becomes what? 6x squared minus 6x plus 4. So this is f prime at x. Of which function? Of this function. So what am I saying to you? I'm saying to you that if you've got a function that puts a lot of smaller functions, because this can be a function on its own, you know that, and then this can also be a function of it on its own, you know that, and then this one can be a function on its own, you know that, and then this one can also be a function of it on its own, and then you know that. So basically, this polynomial is a combination of functions. So basically, if you are given a function that is a combination of functions, and then you are supposed to find the derivative of this function, you separate that function into different components, and then you find each component one day at a time. You don't necessarily have to separate them as in separate and put them far from each other. You just have to make sure that you find the derivative of this one, and then you find the derivative of this one, you find the derivative of this one, and you find the derivative of this one. So when you do get to the university, you'll find out they've summarized this in a nice rule, and then they say that the derivative of the sum is the sum of the derivatives. Okay, so that's basically what you do. That is how you find derivative using the power rules. So these were nice cases, people. Let us just take something else which is not necessarily so nice. Let's say we've got something like this. Let's say you've got f at x, which is equal to root x. Okay, and then they say find f prime at x. Okay, what is going to happen here? What are we going to do? So ladies and gentlemen, before we can continue here, we must then be able, remember we are using the only tool that we have now. The only tool that we have now to find derivative is what? Is a power rule. Right? So because it's a power rule, I will have to make this to be something, and then it must have a power. Okay, so from my own experiences, I know that if you've got square root of x, this is same as what? This is same as x to the power 1 over 2. Can you see that? Yes. So now I've got a base, I've got what? A power. Now that then allows me to use my power rule. Okay, now what do I then do? I take these 2 to this side, and then so I'm going to say 1 and so it's going to be half times x to the power half, right? The one that was already here, but now minus 1. Okay, so what is it then happens? Therefore, this will then give me half x 1 minus half, that is minus 1 over 2. Can you see that? Okay, you can actually use your calculator to check it. You will see it actually comes to that. All right, so this is basically your derivative of what? Of this. Right, before you could derive it, it had to be in a form of where you have something and a power, because you couldn't use a power rule without what? Without power. No power rule, no power, then no power rule. Okay, now in most cases, if not all cases, when you are supposed to find a derivative, they always say something that you must always leave a positive power. So ladies and gentlemen, you all know that if you have something like this, if you have x to the power minus a, this is the same as what? You remember from the rules of exponent that it is equal to 1 over x with a positive a. Okay, so this is a rule. X to the power minus a is same as 1 over a. So we'll also do exactly the same thing here. So what we're going to do is we're going to say, okay, this is same as 1 over 2 times 1 over x to the power 1 over 2. Now what is x to the power 1 over 2? This is same as what? This is same as 1 over 2 times 1 over root x. You remember here we said this is equal to this, so it means this is equal to this one. So now you've got a fraction being multiplied by another fraction, and you know when you have that, you multiply a numerator by a numerator. So here 1 times 1, you get 1, and then 2 times root x, it then becomes 2 root x. Does that make sense? So what does this thing say? So basically what it says here is that when you've got something like this, then the derivative of this, so f prime at x is equal to this. Okay, if you did not hear this thing properly, you can always go back. You know how to go back, and then you can just check. But basically here is what you are given, and then this is what you ended up with. Okay, does make sense? Right, now let's go a little bit further. Let's say you've got y, which is equal to x to the power minus 2. Now things are nice here. There is something here. There is what here? There is a power. So there is a power. So you're going to use what? A power rule. So what do then do? You take this to this side. So you will have dy over dx, which is nothing other than minus 2x. And then you have minus 2 minus 1. Remember we said you always minus with 1. It's a rule. Okay, so basically at the end of the day you get minus 2 and then minus 1 minus 2. So the minus 2 minus 1, that will give you what? Minus 3. And then guys, because you know that you always have to end up with something with a positive power, you then will know that this is same as minus 2 times 1 over x to the power 3, in a way that we did it earlier. And then this then gives you what? Remember there's an invisible one here. Minus 2 times this one is going to be minus 2, and then 1, this is invisible, times x to the power 3, x to the power 3. That is your answer. Okay, let's go on to a little bit more complicated, guys. This is for grade 11. And another thing, guys, when you are watching this thing, this movie, if you want similar videos like this, go ahead and subscribe to this channel, and then click a notification button so that whenever I add videos, because there are so many videos that I'm still gonna add, but if you click a notification button, then they will let you know that I've loaded a video. Then you can go to YouTube and do what, and then you can go there and then enjoy mathematics. Okay, and this is for grade 12 people. This is for grade 12. Okay, now let's say I've got y, which is equal to 1 over x to the power 3, and then they say I must look for dy over dx. So what do I do? Guys, there is a power here, we agree, but this power is in the denominator part. We cannot use power rule if the power is in the denominator part. The power must be here, must be here on the numerator part. Okay, so we use the same rule that we used earlier. Remember, what did we say earlier? We said x. We said if we've got x to the power minus a, that is same as what? We said this is same as 1 over x to the power a. Okay, so now we've got this situation. Remember, when you are saying equal, it means this is equal to this, but at the same time this is also equal to this one. So now we've got this situation, so we can take this situation to something that looks like this. So how do we then do that kind of a thing? So what we'll do is we'll then say, okay, this is same as nothing other than 1 over, sorry, not 1, it's going to be x to the power minus 3. Can you see that? X to the power minus 3. So this is this thing in a power form, so that we can be able to use our very powerful rule, which is then called the power rule. So how do we then go forward with this? We then say dy over dx, then we use the normal power rule, take this thing to this side, we'll get minus what? Minus 3x, and then minus 3 minus 1, and then which is going to be minus 3x to the power minus 4, and then obviously you know you have to put in a positive power, so I'm not going to do all the steps, you know how to do it. So it's going to be minus 3 over x to the power 4. Does it make sense? Does it make sense? Okay, now let's go on a little bit more further, and then let's just close shop after that. Now let's say that we've got something like this. We've got something like this one. We've got y, which is equal to 1 over, say, okay, I think I must do this one first before I even continue. Sorry. Okay, let's wait for this thing to clear. Okay, so let's say we've got y, which is equal to, you've got 3 here, and then you've got x, and then they say you must find dy over dx. Okay, we have a rule. What is the rule? The power rule. So we need a power somewhere. Okay, now from the surds rules, exponent surds rules, you know that if you've got something like this, therefore this is same as, so if you have something like this, so for example, if you, okay, let me use a different color so that I can distinguish it. So if you have x to the power a, and then you've got b here. So if you want to represent this thing in a power format, you will take this x to the x as it is. So you will say this is same as x. But now this a that is here, you will move it up. So you end up with x to the power a on top, and then you say divide, and then you take this one, this b that is here, and then you shift it to this side, and then so you then become x to the power a b. Can you see that? Okay, wonderful. So in this particular case, here we'll also have x, but in a place of a there is what? There is 1. So you take this one to top, and then you have 1 here. Can you see that? And then divide it by, and then you take the number that is here, you put it where? You put it here. So divided by 3. So you've got x to the power 1 over 3. So now you have something in it in terms of a power. Therefore, you can use what? You can use the power rule. So how do you then use the power rule? Going forward, you use the power rule in a very same way. You take this to this side. You will have 1 over 3, and then x, and then you've got 1 over 3 minus 1. So this will then give you 1 over 3. Okay? And then what is 1 over 3 minus 1? I know you guys are lazy, you like using calculator, so let me also use it. 1 over 3 minus 1, then you get minus 2 over 3. So 1 over 3, and then you've got x to the power minus 2 over 3. And then you know guys, 2 over 3. Let me write it properly so that you can see. Yes. So you know guys that you have to leave it in a positive power. So you then have 1 over 3, and then you've got x, and then to the power positive 2 over 3. Can you see that? Okay, it looks very small, but I hope you can see, and you can also correspond with what I'm writing here. All right. These are a little bit more complicated kind of derivatives. Okay. And then let's go just one further. Now, lastly, I think this is the last one, ladies and gentlemen, personalities. Let's now say that you have something like this. You've got f at x, which is equal to, say, x squared plus 4x plus 4. Okay, and then this is divided by x plus 2. And then they say find f prime at x. Now, how do you then deal with a case like this? Ladies and gentlemen, there is a rule in mathematics that deals with how to find the factor of a function, which is a function divided by another function. But obviously, it is beyond the scope of grade 12, of which is what we are currently doing. Okay, so whenever you find something like this, you must know that you must find a way to what? To cancel this one. So that means we must factorize this one at the top so that we can cancel this one, and we can see what we can do after that. So before we even get to this f prime at x, so what we will do is that we will factorize this, and then when you factorize this, we can see that this is the same as x plus 2 and then x plus 2. When you multiply this thing, you get exactly this one divided by x plus 2. Can you see that? Can you see that? Yes. So because of that, then this x, then you will cancel this one. So basically, your f at x will then remain what? Your f at x will then remain x plus 2, just x plus 2. And then when we have x plus 2, the derivative of x plus 2 is nothing other than the derivative of x is what? Is 1. So you've got 1. The derivative of 2 is what? Is 0. So you end up with 1. Let's do another example, and then close shop after that. Let's say we've got y, which is equal to x squared plus 3x minus 5 all over x plus 5. and then they say find dy over dx. So how do you then go about here? Ladies and gentlemen, personalities, we do it in the same way as we did earlier. We need to divide something, because when you have a division, fractions are nice things to work with, but life is so much better without them. Okay, so we also take that format. So basically, so what we'll then do in this case, you will do the same thing that we did earlier. So if you factorize this thing, you will then see that, okay, you always open the factor and then, okay, you can't find the f as x first because your function is still demarcar. Okay, so you've got this x plus 5 that was already here. So when you factorize here, this is x and x, and then when it comes to okay, sorry, I made a mistake here. There's supposed to be 10 here, minus 10. Can you see that? So it's x to the power 2 plus 3x minus 10. Okay, so basically, so it's going to be x, and then the 10, you know, is going to be 2 and 5. You can use any other method of factorizing and then end up finding a factor. And then so basically, you know that okay, this is negative, so it's negative and positive. So negative, okay, so but because the number in the middle is positive, so the positive will need to be here, and then you have minus here. Can you see that? So you end up with something like this. Okay, so this will then cancel this one. Can you see that? And then you will then remain, you haven't even gone to, so this is not f at x, this is y, because they call it y here. So you haven't even found derivative, so y is now x minus 2. Okay guys, I think I need to emphasize this. There is a mark for the things that you do here, so it's not going to be a job that you do and then nothing happens. So when us as teachers, we give you this, we know that you are supposed to do what? We know that you need to divide things here, so we give you a mark for that. So you end up with something like this, and then eventually, so dy over dx then becomes the derivative of this, which is 1, and then derivative of this, which is 0, and then you end up with 1. All right, okay guys, before I close, I just want to mention that we have f at x. Remember, that is how we can call a function, and sometimes we call it what? We call it y. Okay, now when it comes to the derivative, sometimes they will call it f prime at x. That is how they will call it, but sometimes they will call it what? They will call it dy over dx, as we have seen earlier. Okay, but sometimes they will call it dx, but sometimes also they can call it d over dx. Okay, so whether they put this or they put this or they put this or they put this, that is exactly the same thing. They are looking for the derivative, and what are we going to use? We are going to use the power rule. So ladies and gentlemen, personalities, thank you very much for tuning in. This was calculus, how to use a power rule in calculus, which will give you a lot of marks in paper 1 of grade 12 final exam. Thank you very much guys. Don't forget to share this with your friends. There is a link here where you can share in your Facebook so that they can also benefit. Thank you very much guys, and have a lovely day, and goodbye. Thank you.